हाय एवरीवन, दिस इज मैं। और मैं आपको बताना चाहूंगा कि हम अल्कोहल को रिडक्शन ऑफ एल्डिहाइड्स एंड कीटोन्स करेंगे के बारे में आज बात करेंगे। तो जो एल्डिहाइड और कीटोन्स होते हैं उनकी रिडक्शन करा सकते हैं हम यूज करके रिड्यूसिंग एजेंट्स, जो कि हैं हमारे LiLH4 और NaBH4। और हाइड्रोजन यूज कर सकते हैं प्लेटिनम के साथ, और प्लेडियम यूज कर सकते हैं, और निकल यूज कर सकते हैं, और हम यूज कर सकते हैं सोडियम विद C2H5OH। जो रिडक्शन होती है एल्डिहाइड और कीटोन्स की विद सोडियम और C2H5OH, उस रिडक्शन को हम ब्लैंक बोवियल रिडक्शन बोलते हैं। सर, जो हमारे एल्डिहाइड्स होते हैं और जो हमारे एस्टर्स होते हैं वो हमें रिडक्शन पे LiL जो रिड्यूसिंग एजेंट है, जैसे कि LiAlH4, वो हमें देते हैं क्या, 1 डिग्री एल्डिहाइड्स प्रोवाइड करते हैं। 1 डिग्री एल्डिहाइड्स देते हैं, जैसे कि CH3 कार्बन डबल बॉन्ड लो। और जो कीटोन्स होते हैं हमारे, वो हमें 2 डिग्री।
बेटा ये तो आपने आगे लिखा था एल्डिहाइड, ये तो एल्कोहल देंगे ना बेटा। और
हाँ
स्ट्रक्चर
हाँ,
आपने कार्बोक्सिलिक एसिड की बना दी, स्ट्रक्चर जो है कार्बोक्सिलिक एसिड की बना दी। चलो करो आप कंटिन्यू।
और जो हमारे जो कीटोन्स होते हैं वो हमें 2 डिग्री अल्कोहल प्रोवाइड करते हैं जब हम उनको रिड्यूसिंग एजेंट के साथ रिएक्ट कराते हैं, जैसे कि LiAlH4। और अब हम देखते हैं कि
वैलेंसी पूरी करो बेटा, एच लगाओ सी के नीचे, सी के नीचे एच लगाओ सिंगल बॉन्ड।
अब देखते हैं हम कि अगर हमारे पास सेम नंबर ऑफ कार्बन एटम्स हों अगर एल्डिहाइड्स में, वो हमने देख लिया कि हम कर सकते हैं LiLH4 के साथ डायरेक्ट। लेकिन अगर हमारे पास जो एल्डिहाइड्स है, अगर मोर नंबर ऑफ कार्बन एटम्स आ जाते हैं या फिर लो नंबर ऑफ कार्बन एटम्स आ जाते हैं, और उससे हमें हाई नंबर ऑफ कार्बन एटम की अगर अल्कोहल बनानी है, तो वो हम कैसे बना सकते हैं। तो जैसे कि एग्जाम्पल के तौर पर, जैसे कि मिथनल है हमारे पास, जो एल्डिहाइड है उसको हमें कन्वर्ट करना है मिथनॉल में, जो कि सेम नंबर ऑफ कार्बन एटम था जो कि हमने पहले देखा। अगर हमारे पास एग्जाम्पल में अगर आ जाता है कि मिथनॉल को हमें कन्वर्ट करना है इथनॉल में, जो कि लो नंबर ऑफ कार्बन एटम्स हैं जिसके अंदर, तो हम उसको कैसे कन्वर्ट कराएंगे। तो उसके लिए जो मैकेनिज्म है वो हमें यूज करना पड़ेगा। सॉरी, और इसको हमें कन्वर्ट कराना है इथनॉल में, तो कैसे कराएंगे। इसको हम कराएंगे RMgX के साथ रिएक्ट कराएंगे। जो MgX होता है, जो मैग्नीशियम होता है उस पर नेगेटिव चार्ज होता है, जो हमारा आर, सॉरी, जो मैग्नीशियम होता है उस पर पॉजिटिव चार्ज होता है, और जो आर होता है उस पर नेगेटिव चार्ज होता है। जो ऑक्सीजन होता है उस पर लोन पेयर होते हैं, 2 लोन पेयर होते हैं। तो क्या होगा, ये जो हमारा कॉम्प्लेक्स फॉर्म हो जाएगा इस जिससे जिसमें कि क्या होगा कि आर हमारे कार्बन के साथ जुड़ेगा, क्योंकि ऑक्सीजन पे क्या होगा, हमारा नेगेटिव चार्ज आया जाएगा, इसलिए मैग्नीशियम ऑक्सीजन के साथ जुड़ जाएगा। उसके बाद हम इसकी हाइड्रोलिसिस करा देते हैं,
नीचे क्या गैस लिखो।
हाइड्रोलिसिस करा देते हैं। हाइड्रोलिसिस कराने पर हमारा मोर नंबर ऑफ कार्बन एटम का अल्कोहल फॉर्म हो जाता है। फिर आते हैं हमारे अगर लो नंबर ऑफ कार्बन एटम हो एल्डिहाइड में, और हमें, हाँ, अगर ये हमने देखा था कि लो नंबर ऑफ कार्बन एटम से हाई नंबर ऑफ कार्बन एटम का हमने क्या, अल्कोहल बनाया था। और अगर हमें हाई नंबर ऑफ कार्बन एटम से लो नंबर ऑफ कार्बन एटम बनाना हो, तो उसके लिए क्या मेथड है हम यूज करेंगे। जैसे कि हमें कन्वर्ट कराना है इथेनॉल को, इथेनॉल को मिथेनॉल में। तो उसके लिए हमें कंसंट्रेटेड HNO3 यूज करना होगा। कंसंट्रेटेड HNO3 क्योंकि एक स्ट्रॉन्ग ऑक्सीडाइजिंग एजेंट होता है, ये इसको कन्वर्ट कर देगा किसमें, हाई नंबर ऑफ कार्बन एटम के कार्बोक्सिलिक एसिड में। हाई नंबर ऑफ कार्बोक्सिलिक एसिड को कन्वर्ट करा
तो सेम रहेगा
सर, अभी कर रहे हैं सर। हाई नंबर ऑफ कार्बन एटम का कार्बोक्सिलिक एसिड होगा जिसको हम रिएक्ट कराएंगे सोडियम के साथ, सोडियम हाइड्रोक्साइड को इन साथ में कैल्शियम ऑक्साइड लेंगे हम, और उसको रिएक्ट कराने के बाद हम फॉर्म करेंगे एल्केन फॉर्म हो जाएगी इसकी वजह से हमारे पास, क्योंकि सोडियम हाइड्रोक्साइड के साथ कैल्शियम ऑक्साइड के साथ रिएक्ट कराने पे
अबे तो मीथेन बनेगा
मीथेन फॉर्म हो जाएगा। मीथेन फॉर्म होने की वजह से फिर हम इसको पहले मीथेन को हमें एल्काइल हैलाइड में कन्वर्ट कराना पड़ेगा, जिसके लिए हम इसको इसकी हेलोजिनेशन रिएक्शन करा देंगे लाइट की प्रेजेंस में, क्लोरीनेशन करा देंगे लाइट की प्रेजेंस में, और जैसे कि हमारा एल्काइल
मीथेन का फॉर्मूला होता है CH4
हमारा एल्काइल हैलाइड फॉर्म हो जाएगा। जो एल्काइल हैलाइड है उसको हम बना सकते हैं, उसको एल्काइल हैलाइड को हमें रिएक्ट कराना पड़ेगा एक्वस KOH के साथ, एक्वस KOH के साथ। तो जो एक्वस KOH होता है, ये जो KOH है हमें OH नेगेटिव देगा। जो OH नेगेटिव होता है वो स्ट्रॉन्ग न्यूक्लियोफाइल होता है देन क्लोरीन, तो वो क्या करेगा, उसको रिप्लेस करा देगा, और जिससे कि हमारी अल्कोहल फॉर्म हो जाएगी। तो हमने क्या देखा कि हमने हाई नंबर ऑफ कार्बन एटम से एल्डिहाइड में लो नंबर ऑफ कार्बन एटम का अल्कोहल फॉर्म किया, इथेनॉल से मिथनॉल फॉर्म किया, जो कि हमारे एग्जाम्स में आ जाती है। थैंक यू।
Hey, hey, this is Sahil from BSc Chemistry Honors, second year, third semester. Today, my topic of presentation is alcohol and its classification. Alcohol are a class of organic compounds which are regarded as hydroxy derivatives of hydrocarbons. And as we all know that hydrocarbons are primarily of two types, that is aliphatic and aromatic. So alcohols are the organic compounds which are formed by the replacement of one or more hydrogen atoms by hydroxy groups. And on the basis of this, the alcohols are classified into monohydric, dihydric, trihydric, and polyhydric alcohols. Monohydric alcohols are the alcohols which have only one hydroxy group, and example is methanol or methyl alcohol. And dihydric alcohols are the alcohols which have two hydroxyl group which are attached to two different carbon atoms. Example is glycol, CH2OH, CH2OH. सर स्ट्रक्चर कैसे देंगे, नोटबुक है। This is glycol, which is an example of dihydric alcohol. Now, third type is trihydric alcohol. These are the alcohols which have three hydroxy group, and these hydroxy group are attached to three different carbon atoms. And example will be glycerol. And this is structure of glycerol. And now, polyhydric alcohols are the alcohols which have four or more hydroxyl groups. And example is sorbitol. Now proceeding to the second basis of classification, and on this basis, alcohols are classified into aliphatic alcohols and aromatic alcohols. Aromatic alcohols are the alcohols in which the hydroxy group is attached to the side chain of the जो aromatic hydrocarbon है उनकी side chain से attached होंगे, that is aryl substituted alkyl radical से attached होगा hydroxyl group. Now we'll be talking about phenols. Phenol are the compounds in which the hydroxyl group is directly attached to the benzene ring, and phenols are जो substituted phenol होंगे उनको हम phenols बोलेंगे. And now we will be talking about the third basis of classification, and the basis of classification will be the type of the carbon atom to which the hydroxyl group is attached. So first type is the primary alcohols. Primary alcohols are the alcohols in which the OH group is attached to the primary carbon atom. अब primary carbon atom कौन सा होगा? Primary carbon atom वो carbon atom होगा जिसमें OH group या hydroxy group जिस कार्बन से जुड़ा है वो कार्बन किसी दो हाइड्रोजन एटम से जुड़ा है, एटलीस्ट दो हाइड्रोजन एटम से जुड़ा होगा वो, या तो ये कह सकते हैं कि वो एक कार्बन मतलब जो ग्रुप होगा, जो इनका कैरेक्टरिस्टिक ग्रुप होगा इनमें प्रेजेंट, वो CH2OH ग्रुप जरूर होगा प्रेजेंट. और जो फिर हो गई सेकेंडरी एल्कोहल. सेकेंडरी एल्कोहल्स आर द एल्कोहल्स इन विच द OH group is attached to a the carbon atom which carries the hydroxyl group is attached to two other carbon atoms. इनमें जो कैरेक्टर, या ये कह सकते हैं कि वो एक हाइड्रोजन एटम से अटैच होगा, एटलीस्ट ओनली वन हाइड्रोजन एटम से वो अटैच होगा. और इसका एग्जांपल अगर हम देखें तो डाइहाइड्रिक एल्कोहल में जो कैरेक्टरिस्टिक ग्रुप होगा वो होगा CHOH. और CHOH ग्रुप कुछ इस तरीके से होगा. ये कैरेक्टरिस्टिक ग्रुप है सेकेंडरी एल्कोहल्स का. मतलब इससे हम आइडेंटिफाई कर सकते हैं सेकेंडरी एल्कोहल्स को. सो नाउ विल बी टॉकिंग अबाउट टर्शरी एल्कोहल्स. तो टर्शरी एल्कोहल्स आर द एल्कोहल्स इन विच द हाइड्रोक्सी, जिस कार्बन से हाइड्रोक्सी ग्रुप अटैच होगा वो कार्बन फर्दर तीन कार्बन एटम से अटैच होगा, और उनका जो कैरेक्टरिस्टिक ग्रुप होगा वो ये होगा. और जो मोनोहाइड्रिक अल्कोहल्स होते हैं उनमें अगर हम आइसोमेरिज्म की बात करें तो वो स्ट्रक्चरल आइसोमेरिज्म दिखाते हैं, पोजीशन आइसोमेरिज्म. जो मोनोहाइड्रिक अल्कोहल्स होते हैं वो तीन तरीके की आइसोमेरिज्म दिखाते हैं: स्ट्रक्चरल आइसोमेरिज्म, पोजीशन आइसोमेरिज्म एंड फंक्शनल आइसोमेरिज्म. स्ट्रक्चरल आइसोमेरिज्म में जो पेरेंट चेन का स्ट्रक्चर है वो ही वेरी करेगा, जैसे एन ब्यूटाइल अल्कोहल हो गया या आइसोब्यूटाइल अल्कोहल हो गया. और जो जो पोजीशन आइसोमेरिज्म होगा उसमें जो लोकेंट वेरी करेगा, मतलब जिस कार्बन से जो OH ग्रुप अटैच है वो वेरी करेगा, लाइक ब्यूटेन 1 ओल ब्यूटेन 2 ओल हो गया. फंक्शनल आइसोमेरिज्म वो होगा जिसमें फंक्शनल ग्रुप ही चेंज हो जाएगा. फंक्शनल ग्रुप चेंज होगा मतलब ये बेसिकली आपके एस्टर्स के साथ शो करते हैं सर, ईथर के साथ. थैंक यू.
Good morning, everyone. Myself Tanisha from BSc Chemistry Honors second year. My topic is phenol and its preparation. Phenol and its preparation. Phenol is also known as carbolic acid and benzoyls. The word phenol is originated from two words, phenyl plus enols. They are classified as three: first, monohydric; second, dihydric; and third is trihydric phenols. According to they contain one carboxylic group, two carboxylic group, and three carboxylic group. Examples of monohydric phenols: cresol, orthocresol, metacresol, or paracresol. Examples of dihydric phenols: resorcinol. Trihydric, pyrogalol, in which three hydroxyl group attached to benzene ring. Preparation of phenols. Phenols can be prepared from sulfonic acid. H2S2O7, in which benzene reacts with H2S2O7 and form SO3H, sodium, benzene sulfonate. This reacts with NaOH and form phenol plus Na2SO3. By this way we can prepare phenol. Second, by heating chlorobenzene in the presence of catalyst under high temperature and pressure. Thank you.
Good morning, one and all. I, Purva Kataria from class BSc Chemistry Honors second year, here before you to give a quick overview over the topics of organic compounds called ethers. The organic compounds having COC functional group with ROR ROR general formula are called ethers, where R and R may be aryl or alkyl groups, or maybe one is aryl group and the other is alkyl groups. They are classified into three types, which are mainly called aliphatic ethers, aromatic ethers, and cyclic ethers. Aliphatic ethers are the ethers which have R and R dash be the same or two different carbon chains. In aromatic ethers, there is one aromatic group and the other is single carbon chain are called aromatic ethers, and the ethers in which the oxygen is present in the ring are called cyclic ethers. There are many ways of formation of ethers, which include from alkyl halides, from alcohols, from alkenes, and from Grignard reagent. In alkyl halide formation type, we have Williamson synthesis, in which alkyl halide is treated with corresponding sodium alkoxide, and there is also a formation in which alkyl halide is treated with dry silver oxide to form ethers. In the formation by alcohols, there are different type of methods, which include dehydration of alcohols, which is consisted of two mechanisms, that is SN1 and SN2 nucleophilic mechanisms. In the formation from alkenes, there are two different types of methods, mainly called acid catalyzed dehydration and catalyzed dehydration. The next and the last is from Grignard reagent, in which the alpha haloether is treated, the alpha haloalkane is treated with suitable Grignard reagent. For example, methoxychloromethane is treated with suitable Grignard reagent to obtain ethyl methyl ether, and the side product as chloromethane iodide. There are many physical properties, including boiling point, solubility, and many more, and the dipole nature, in which solubility is the solubility of lower ethers with 1, 2, and 3 carbon chain members, which are soluble in water. That is so due to the hydrogen bond they form with water. The boiling points of the ethers are comparatively low, and they have dipolar nature due to CO-C bond, where one CO and the other CO is having two different dipole natures correspondingly. And they are now we are done with physical properties, and here comes the chemical properties, which include the reaction of involving cleavage of carbon oxygen bond do not involving cleavage of carbon oxygen bond and involving the alkyl groups. Thank you. Good morning, everyone. Today I, Amni, student of BSc Chemistry Honors second year, is hereby to present a short overview on topic phenols. So phenols are a class of organic compounds in which hydroxyl group is attached to a benzene ring. Depending upon the number of hydroxyl group attached on benzene ring, it is classified as monohydric, dihydric, trihydric, and for more we can use polyhydric term also. Phenols are used in many industries and in the manufacture of number of products, also used for medicine as antiseptic or disinfectant. If we talk about its structure and bonding, then first of all about its orbital structure, then phenols or about orbital structure, then carbon and oxygen bond is formed by overlapping of sp3 and sp3 sharing of orbital, that is they are forming sigma bond, and between oxygen and hydrogen by sp3 and 1s orbital sharing. Carbon and oxygen bond length is 136 parameter, which is less than methanol because they show double carbon character, and the bond angle between carbon, oxygen, and hydrogen is 109 degree. Due to their polar nature, phenols have intermolecular hydrogen bonding. Further moving to its preparation, then phenols can be prepared by various methods, like from cumene, from decarboxylation of even from aryl halides, and furthermore, phenols are moving to its physical properties, and phenols have many physical properties, like if we talk about its physical state, then pure phenols are colorless liquids or solid. They turn reddish brown on oxidation, and boiling point of phenols are higher like alcohols due to intermolecular hydrogen bonding. Solubility of phenols, if we talk about the solubility of phenols, then phenols are soluble in less soluble in water than alcohol because of the larger benzene ring, because of the presence of benzene ring. Now further moving to its acidic character, then phenols have ability to show acidic character due to due to loss of hydrogen ion to form phenoxide ion. They are more acidic than alcohols because phenols form stable phenoxide ion, which can due to resonance effect, and alcohols form alkoxide ion, which is less stable. The subsequent effect on alcohols can be explained as electron withdrawing group. If electron withdrawing group is attached to a benzene ring, then the acidic character of phenol will increase. And if electron donating group is attached as substituent group, then acidic character of phenols will decrease. The acidic weakening and strengthening effect is shown more on para and ortho position than at meta position because of this can be explained by resonance and inductive effect. Now, the phenols also show some important chemical reactions, like from Williamson synthesis for ester formation. For ether formation, we can do by acylation. Then it also react with zinc dust. Electrophilic substitution reaction also it shows that by sulfonation, nitration, and Friedel-Crafts reaction, acylation. and furthermore, further moving to the for differentiating alcohols and phenols, we can show by bromine water test. When a phenol is shaked with bromine water test, then it shows white PPT of 2,4,6 tribromophenol, but alcohols do not. By it, we can also distinguish by the litmus test. Phenols turn blue litmus into red, but alcohols do not turn it. Even by coupling reaction, and phenols react with NaOH, but alcohols do not. Thank you.
Hello, myself Sunida. I am from BSc Chemistry Honors second year, third semester. My topic is alcohols and its classifications.
Alcohols are the species
थोड़ा तेज बोलना बेटा, आवाज तेज।
which are replaced by two or more hydrogen atom in aliphatic chain by hydroxy group are called alcohols. For example, methane is OH is attached and it forms methane. Classifications of alcohols are as first is monohydric, dihydric, and trihydric alcohols. Monohydric alcohols are the alcohols which are formed by the replacement of one hydroxy group. Dihydric alcohols are the alcohols which are formed by the replacement of two hydroxy group, which are formed by the replacement of two hydroxy group. Example is glycol. Trihydric alcohols are the alcohols which are formed by the replacement of three hydroxy group, which are formed by the replacement of three hydroxy group are called trihydric alcohols. Example for this is glycerol. Another classification for this is aliphatic alcohols and aromatic alcohols. These are the species which are replaced by two or more H atom in aliphatic chain
by hydroxy group. For example, and in case of aromatic alcohols, these are those species which are replaced by two or more H atoms in aromatic side chain. By hydroxy group. Thank you.
Good morning, everyone. Myself, Nikita from BSc Chemistry Honors second year, and my topic is alcohols and classification of alcohols. Alcohols are species which are formed by replacement of hydrogen atom from aliphatic or aromatic hydrocarbons. For example, methanol. Alcohols are further classified on alcohols are further of two types: aliphatic hydrocarbons, aliphatic alcohols, and aromatic alcohols. Aliphatic alcohols are alcohols which are formed by replacement of hydrogen from aliphatic hydrocarbon. For example, it will form CH3, CH2, CH2OH, propanol. Aromatic hydrocarbons are aromatic alcohols are alcohols which are formed by replacement of hydrogen from aromatic alcohols by hydroxy group. For example, if we replace hydrogen from benzene ring, it will form phenols. Second method of classification of alcohol is number of OH group present in them. First is monohydric alcohols. If alcohol contain only one OH group, then it is called monohydric alcohol. For example, ethanol. And if alcohol contain two hydroxy group, then it is called dihydric alcohols. And its example is ethane 1,2-diol. And third type is trihydric alcohol. If alcohol contains three OH group, then it is called trihydric alcohol. And its example is glycerol. Monohydric alcohol are further of three types basis on OH
तो
group.
बीच वाले कॉलम CH2 का एक H हटाओ, बीच वाले कॉलम.
Monohydric alcohols are further of three types basis on whether carbon is linked with another carbon or not. It is of three types: primary alcohols. If carbon containing OH group is not linked with any another carbon atom or only one carbon, then it is primary alcohol. For example, ethanol. And second type is secondary alcohol. If carbon containing OH group is linked with two carbon atom, then it is called secondary alcohol. For example, propane, 2-ol. And third type is tertiary alcohol. And if carbon containing OH group is linked with another carbon atom, then it is called tertiary alcohol. For example, an example is 2-methyl propane, 2-ol. Now, types of aromatic alcohols. Aromatic alcohols are alcohols which are formed by replacement of hydrogen from aromatic hydrocarbon by hydroxy group. Then the alcohol formed is aromatic alcohols. For example, phenol formed from benzene by replacement of hydrogen atom. Aromatic alcohols are further of two types: nuclear substituted. Alcohols formed by direct attachment of OH group on main chain, then it is called nuclear substitution. For example, phenol. Second is chain substituted. Alcohol formed by replacement of hydrogen on substitution present on benzene ring. Nuclear substituted are further of three types based on substitute present on whether ortho position, meta, and para position. These are of three types: ortho substituted, meta substituted, and para substituted. If substituent is present on C2 and C6 position with respect to OH group, then it is called ortho substituted. And if substituent is present on C3 and C5 position, then it is called meta substituted. And if substituent is present on C4 position with respect to hydroxy group, then it is called para substituted.
Good morning, everyone. My name is Nikita. I am from BSc Chemistry only second year. Today, my topic is absorption of light. There are two laws which express the relationship between absorption of light and its molar concentration, and the law of length of path each of the substance. First is Beer's law. When a beam of monochrome light is passed through the substance, which absorption of light is directly proportional to its molar concentration of the substance. And second is Lambert's law. When a beam of monochromated light is passed through the substance, the absorption of light is directly proportional to the length of the path of the substance. And when they are combined, these two laws we called as Beer's-Lambert's law. Beer's-Lambert's law, the absorption of light is number of wavelength is directly proportional to the number of molecules of the substance. We can mathematically derive in this way. Logarithm I naught by I directly proportional to C is called Beer's law, and logarithm I naught by I is directly proportional to L. If we can call that Lambert's law, and then we are combined is a constant is constant is called as epsilon, is denoted as E, and we can also say that extends coefficient. And limitation of Beer's-Lambert's law, it is not applicable of sample solution and solvent of interact with each other, but they are combined of UV spectroscopy of the species. Hi, good morning, all of you. Myself Rakhi, and today's my topic for the presentation is alcohols and its proper alcohols and its classifications. So, alcohols are those species which are formed by the replacement of one or more H atoms from the aliphatic hydrocarbons or the side chain of the benzene ring by the hydroxy group. So, first of the classification of alcohols is aliphatic alcohols or aromatic alcohols. Aliphatic alcohols are those alcohols which are formed by the replacement of one or more H atom from the aliphatic hydrocarbons by hydroxy group. And second is aromatic alcohols. Aromatic alcohols are those alcohols which are formed by the replacement of one or more H atom from the side chain of the benzene ring by the hydroxy group. The second way of classification of alcohols is first is monohydric alcohols, second is dihydric, and third is trihydric alcohols. Monohydric alcohols are those in which one OH group is contained. Second is dihydric alcohols, the alcohols in which two OH group is contained. Third is trihydric, in which three OH group are contained. Types of monohydric alcohols. First is primary alcohol. The primary alcohol in which the primary alcohols in which OH group containing one or no carbon atom. Second is secondary alcohol. Secondary alcohols are those in which OH group is further linked with two carbon atoms. Third is tertiary alcohol. Tertiary alcohol in which the OH group is further linked with three carbon atoms. Thank you.
Good morning, all of you. My name is Ajay Vasisht. I am student of BSc Chemistry on the second year. Today is my topic mono, di, and tri hydric alcohol. So, which contain one OH group. It is saturated carbon chain. Example: CH3, CH2, OH, dihydric alcohol, alcohol, which contain two OH. Carbon chain. Alcohol which contain 3OH group saturated carbon chain. These three OH. Thank you very much.
Good morning, everyone. Myself Vinith. I am student of chemistry honors second year. Today's my topic is monohydric alcohols. The compounds or alcohols to which only one single OH group is attached to the aromatic carbon chain are called monohydric alcohols. On the basis of the classifications, there are three types of monohydric alcohols: primary alcohol, secondary alcohol, and tertiary alcohols. Primary alcohols are those alcohols in which the carbon atom of the hydroxyl group is attached to single alkyl group. Example of primary alcohols are ethanol and methanol and etc. Secondary alcohols are those in which the carbon atom of the hydroxyl group is attached to two alkyl groups. The two alkyl groups present may be structurally identical or different. Examples of secondary alcohols can be considered as isopropyl alcohol and so on, etc. On the basis of classification, the third type of alcohol is a tertiary alcohol. Tertiary alcohols are those in which the carbon atom of the hydroxyl group is attached to three alkyl groups. Examples can be tertiary butyl alcohol and so on. So this was my topic for the day. Thank you, everyone.
Thank you. I am Pranav. I am from class BSc Chemistry honors second year. And my topic is McMurray reaction. This is an organic reaction in which either ketone or aldehyde group is coupled to form an alkene compound. This was named after its co-discoverer John McMurray. The reagents which are used during McMurray reaction are first the originally reagent which was used is titanium chloride or titanium 3 chloride and a reducing agent LiAlH4, which is lithium aluminum hydride. Another reagent which can be used during this McMurray reaction is PiCl4 with any of the metal such as potassium, copper, zinc, or couple of copper and zinc. Now I will give an example of this reaction. Example. It is benzophenone. In the presence of LiAlH4 as a reducing agent and TiCl3, it will form an alkene. It is an alkene. Thank you.
Good morning, everyone. I'm Isha from BSc Chemistry on the second year. The topic of my presentation is ethers. Ethers, these are the compounds which contains a functional group in their structure. The common formula of ethers are ROR, where R refers to the carbon chain. Classification of ethers. Ethers can be classified into two main categories: acyclic ethers and cyclic ethers. Acyclic ethers are those ethers in which O atom is present in is not present in a ring. These are called acyclic ethers, whereas when O atom is present in a ring, they are called cyclic ethers. Further, acyclic ethers are divided into two main categories: aliphatic ethers and aromatic ethers. Aliphatic ethers, when both the substituents present around the O group are alkyl groups, then the ethers are called aliphatic ethers, whereas when both the substituents present around the O functional group are aryl groups, then the ethers are called aromatic ethers. Aliphatic and aromatic ethers are further divided into symmetrical and unsymmetrical ethers on the basis of substituents present around the oxygen atom. When both the substituents present around the oxygen atom are same, then the ethers are called symmetrical ethers, whereas when both the substituents present around the O functional group are different, then the ethers are called unsymmetrical ethers. Physical properties of ether. Weak van der Waals forces of attraction are present between the molecules of ether. They do not show molecular association due to the presence of weak van der Waals forces present between the molecules. Ethers have low viscosity. They have low boiling point due to the presence of weak van der Waals forces of attraction, because less heat is required to break the bond. The lower member of ethers are gases, whereas higher member of ethers are liquid due to increase in magnitude of van der Waals forces of attraction. Ethers are less soluble in water. The lower member of ethers are comparably more soluble in water, whereas the higher members of ethers are less soluble in water because hydro. Good morning, everyone. I am Lisa from BSc final year. Today, I will tell about the organometallic compound. Organometallic compound, whose compound which contain metal and carbon bond. Metal and carbon bond. This is called organometallic compound. And for example, Grigant reagent alkyl lithium alkyl lithium alkyl genic bond. Organometallic compound have two types: simple organometallic compound and mixed organometallic compound. Simple organic compound which contain metal and carbon bond. And mixed organometallic compound whose bond between metal and metal carbon halide. Cyanide does not organometallic compound because they do not contain organometallic properties. First of all, organometallic compound Grigant reagents. Whose formula R MgX, R alkyl group, Mg magnesium or X amine halide. We can prepare Grigant reagent from the alkyl halide.
we take reagent Na and try one of the most important solvent tetrahydroquinone, which is very good reagent in very good reagent. And now we can reaction or we can reaction we can prepare or get present from the alkylide reaction dry ether and NATKH solvent, and we can prepare reagent presents a very reactive, but alkyl lithium is very more reactive than the reagent reagents.